Hey everyone, and welcome to another deep dive.
It's great to be here.
Today we're going to be looking at performance and scalability for software development
Yeah, we've got a whole bunch of tips and tricks
from all of our sources.
for making software run faster and smoother,
Exactly. And it's for everyone from beginners.
all the way up to experienced pros.
Yeah. So if you're a software developer looking to write code that can handle anything you throw at it,
Yeah.
you are in the right place.
All right, so let's dive right in. The first thing that really jumped out at me was this idea of boxing and unboxing.
Oh yeah.
And at first, I have to admit, I was imagining like
Like unpacking a brand new phone.
Exactly.
It's not quite that exciting in the programming world.
So what is it?
So imagine you have a simple number like the number 5.
Mm-hmm.
It's a primitive data type, which means it's very lightweight and efficient.
Okay.
But sometimes you need to treat it as an object.
Okay.
Like if you want to store it in a collection,
Uh-huh.
like a list that only accepts objects.
All right. That's when you box it.
Okay.
You basically wrap it up in an object container.
So it's like taking something really small and putting it in a giant box.
Exactly.
So why is that bad?
So the problem is that each time you box a value, you're creating a new object on the heap,
And the heap is,
which is the memory space where objects live.
oh, okay.
This allocation takes time and resources,
Hmm.
and then you have to unbox it,
Right.
which means you have to take it out of that box to use it as a simple number again,
Right.
and that adds even more overhead.
And what if you're doing this like a lot?
If this happens repeatedly, like inside a loop
Right.
that runs thousands of times, it can really slow down your code.
It's like you're wrapping a gift and unwrapping it over and over again.
Exactly. And all those temporary objects created by boxing need to be cleaned up eventually.
And who does that?
And that's where the garbage collector comes in.
Ah, okay.
So the more garbage it has to collect, the harder it has to work,
Yeah.
which can actually lead to noticeable pauses in your
Oh.
application.
Okay, so the takeaway here is try to avoid too much boxing and unboxing.
Exact.
Like stick to primitive types when you can.
Especially within frequently executed code blocks.
Okay, makes sense. Well, let's move on to something that sounds a little bit more like a magic trick to me.
Okay.
It's tail recursion.
Tail recursion. It's a very cool technique.
So what is it?
So let's start with recursive functions,
Okay.
which are functions that call themselves.
Mm-hmm.
And each time a function calls itself,
Okay.
it adds a new frame to the call stack.
Mm-hmm.
And the call stack is basically what keeps track of where the program needs to return to
Right.
after the function call complete.
So if you have a function that calls itself too many times.
If the recursion goes too deep, you can get something called a stack overflow error,
Oh, right. I've heard of those.
which can crash your program.
So tail recursion helps prevent that.
Tail recursion helps prevent that. It's all in how the recursive call is structured.
Okay.
With tail recursion, the recursive call is the very last thing the function does.
Right.
And that allows the compiler to optimize the execution by basically reusing the current stack frame
Okay.
for the recursive call instead of creating a new one.
Oh, so it's kind of like folding them in on themselves.
Exactly.
So the stack doesn't just grow forever.
Exactly. It's a very clever space-saving technique.
Right. So you can rewrite recursive functions to be tail recursive
In many cases, yes.
without changing what they do.
Exactly. You don't have to
And-
change the core logic.
So you can just make them more efficient.
It's like finding a secret efficiency switch.
I like that. Okay, so speaking of efficiency, let's talk about Scala views.
Scala views.
This one sounds like it could be useful for really, really large amounts of data,
Oh, for sure.
like big data.
Absolutely. They're incredibly powerful for working with large data sets.
So what are they?
So imagine you have this massive amount of data and you want to do a bunch of operations on it,
Right.
like filtering, mapping, sorting.
Mm-hmm.
But if you do those eagerly, meaning you create a new collection after each step,
Okay.
you could end up with a lot of extra copies of that data,
Right.
wasting memory and processing power.
So views are like a way around that.
Use your way around that. So a view is basically like a blueprint
Okay.
for transformations on a collection.
Okay.
And it doesn't actually execute those operations until you need the results.
Okay.
It just remembers what you want to do.
So you could do a bunch of different things to the data.
You can chain all sorts of operations on a view
Oh.
without creating those intermediate collections.
Right.
So you're saving a lot of resources
Then memory.
and memory. And what's even cooler is that it only computes
Okay.
the elements that you actually need.
Oh, wow.
So if you only end up accessing a small part of the data,
Right.
the rest of those computations never happen.
So it doesn't do work it doesn't need to do. Very cool.
Yeah.
It's all about being lazy.
In a good way.
In a good way, exactly. So these sound like a really essential tool
They really are.
for anyone working with large data sets.
Absolutely. If you want to write efficient and elegant code,
Right.
Scala views are definitely something to look into.
This is all great stuff.
It is.
We've already uncovered some really amazing things you can do to make your code more efficient,
For sure.
like being smart about how you use objects,
Right.
optimizing those recursive functions,
Yes.
and figuring out how to handle those really, really large data sets
Absolutely.
without bogging everything down.
It's all about those little details,
Yeah.
making small changes that make a big difference.
All right, so I think we should dive into the next set of techniques
Let's do it.
and see what other secrets we can unlock.
I'm excited.
Me too.
So let's move on to something a bit different now.
Okay.
It's called event sourcing.
Event sourcing.
Okay. And it's a really interesting way to think about managing the state of your system.
So what does that even mean, managing the state of your system?
So instead of just storing the current state of your application,
Okay.
you actually keep a log of all the events that have happened over time.
Hmm.
Think of it like a detailed history of
Right.
everything that's happened.
So every action, every change.
Exactly. Things like a user creating an account,
Okay.
placing an order,
Mm-hmm.
updating their profile.
Okay.
All of those things are events.
So you're not just looking at like a snapshot of where things are now.
Right. It's not just a snapshot.
You're looking at everything that led up to it.
Exactly. So how do you think this could be helpful?
Well, I guess for one thing, you would have a really good record of what happened.
You'd have a perfect audit trail.
Right.
You could see exactly what happened and when it happened.
And that would be good for like debugging.
Absolutely. If something goes wrong, you can go back and see exactly how you got there.
And that could be really helpful for complex systems.
It's invaluable for understanding how your system evolved over time.
That makes sense. Is there anything else?
Well, it can also be great for scalability.
Okay.
Since you're just adding events to a log,
Right.
you can distribute that log across multiple machines.
So you could handle a lot more data.
Exactly. You can handle huge amounts of traffic and data very efficiently.
So it makes it more resilient.
Absolutely. And since you're not constantly updating a central database,
Right.
you can avoid a lot of the problems that come with concurrency.
Like race conditions and all that stuff.
Exactly. You can get rid of a lot of those bottlenecks.
But wouldn't it be really slow to have to go through the entire log every time you need to do something?
It's a valid concern,
Yeah.
but there are ways to optimize that.
Okay.
You can create snapshots of the state at certain intervals.
So like checkpoints.
Exactly.
Right.
Like bookmarks in a book.
So you don't have to read the whole thing every time.
Exactly. You can just jump to the relevant section.
That's really clever.
Yeah.
Okay, so this sounds like a really interesting way to manage data,
It's a powerful pattern.
but it's not like a quick fix.
It requires a different way of thinking about your system.
Yeah, you're really focusing on the changes over time.
It's a very event-centric approach.
Well, let's move on to something a bit more concrete.
Sure.
This one is the blocking construct in Scala.
The blocking construct.
And this is for handling those tasks that take a long time, right?
It is.
Okay, so why do we need something special for that?
So asynchronous programming is really important for building applications that are responsive and scalable because it lets tasks run in the background without blocking the main thread.
Right.
But sometimes you have operations that just can't be asynchronous.
Okay.
Like maybe they involve interacting with a really slow external system
Okay.
or doing some heavy computation.
So they could hold up the entire application.
They can cause major slowdowns if you're not careful.
So this blocking construct is how you deal with that.
Exactly. So the blocking construct is basically a way of telling the execution context. Okay.
That a particular piece of code might block.
So it's like a warning sign.
It is.
Yeah.
You're basically saying, hey, this might take a while.
Be prepared.
And the execution context can then adjust accordingly.
Okay. So how does it adjust?
So for example, the default global execution context in Scala
Right.
will increase the number of threads in its pool
Okay.
when it encounters a blocking operation.
Okay. So it can bring in more workers
Exactly. It brings in reinforcement.
to help handle the load.
Exactly. And that helps prevent those blocking operations from slowing down the rest of your application.
Makes sense. So it's a way of managing concurrency
It is a really useful
and
mechanism.
making sure that everything runs smoothly.
Exactly. It helps prevent thread starvation.
Right. Because otherwise one task could just hog all the resources.
Exactly. So you want to make sure that all of your threads have a chance to run.
So this blocking construct is a really useful tool
It is.
for making sure that your application stays responsive. Absolutely, even when you're dealing with those slow or unpredictable operations.
Okay, now let's talk about something that sounds a little bit more futuristic to me.
Okay.
CRDTs.
CRDTs.
Conflict-free replicated data types.
They sound like something out of a science fiction movie.
They really do. So what are they?
So CRDTs are a way of having multiple copies of your data spread across different machines. And you can update any of those copies independently without ever running into conflicts.
Wait, so you're saying you can have two people editing the same data
exactly
at the same time?
And it just works.
And it just works. There are no merge conflicts.
How is that even possible?
So they're based on some very clever mathematical principles that ensure that all updates are commutative.
To mutate, so like addition.
Exactly like it.
So it doesn't matter what order you do things in.
Exactly. The end result is always the same.
Oh, wow. So CRDTs are like the magic bullet for distributed data.
They are incredibly powerful. They just make all the problems go away.
They solve a lot of the really tricky problems.
So where are they used?
They're being used in all sorts of exciting applications.
Like?
Collaborative editing, distributed databases, online gaming.
Wow.
Anywhere you need strong consistency guarantees in a distributed environment.
So they're like the superheroes of distributed systems.
They swoop in and save the day.
I like that. Okay, so CRDTs are all about making sure that everyone has the same data.
Exactly. They ensure strong consistency.
And that brings us to another important concept.
Okay.
Eventual consistency.
Eventual consistency.
This one sounds a little bit more familiar.
It's a bit more down to earth.
Like something I might have encountered in everyday life.
Exactly. Have you ever edited a shared document online?
Oh, sure.
So you and your collaborators might all be making changes at the same time, and sometimes you see slightly different versions of the document as those changes are being synced. But eventually you all see the same consistent version.
Right.
That's eventual consistency in action.
So it's like the data is catching up.
It's eventually consistent.
Okay. And this is used in a lot of systems, right?
It's very common in systems where availability and scalability are really important.
So things like cloud services.
Exactly. Things like cloud storage, online games, social media platforms.
So it's a trade-off.
It is a trade-off.
You're giving up a little bit of consistency.
You're allowing for temporary inconsistencies in exchange for better performance and greater flexibility.
This is a lot to take in.
It is.
We've covered so much ground today.
We have.
From those really detailed things.
Like boxing and unboxing.
Yeah. To these bigger concepts.
Big event sourcing and eventual consistency.
It's really amazing how much goes into building software.
It is a complex and fascinating field.
That can handle all the demands we put on it these days.
Absolutely. And it's only getting more complex.
And more interesting.
Exactly. Yeah, it really is a fascinating area, isn't it?
It is. And it's changing all the time.
Always evolving.
New challenges and new solutions.
Exactly. And our understanding of it keeps getting better.
It's really inspiring to see what people are coming up with.
It is.
But I think it's time to bring this back to our listeners.
Okay.
We've talked about a lot of different things today.
We have.
But what does it all mean for the people who are actually writing code?
Right. How can they use this in their everyday work?
Exactly.
Yeah.
So we want you to think about what you're working on right now.
What are the problems you're facing?
What are the challenges?
Where are the bottlenecks?
Maybe you're working with huge amounts of data.
Or a system that needs to handle thousands of users at the same time.
So think about the things we've discussed today.
Which one stood out to you?
Which ones seem like they could be helpful for your projects?
Maybe it's something small like being more careful about boxing and unboxing.
Or maybe it's something bigger like using Scala views to handle those large data sets.
Or even exploring event sourcing or CRDTs.
The key is to experiment.
To try things out.
And see what works for you.
Don't be afraid to make mistakes.
That's how we learn.
And there are so many resources out there to help you.
Articles, tutorials, online communities.
It's all about learning and growing as developers.
Staying curious and exploring new ideas.
Because this field is always moving forward.
And we need to keep moving with it.
Well said.
So that's it for our deep dive on performance and scalability.
I hope you enjoyed it.
We hope you learned something new.
And until next time.
Happy coding, everyone.